Hi everyone, welcome to EdXP. EdXP is a learning and assessment platform for students to practice, train, and assess themselves outside of the classroom. Today I will cover the topic of exponents and logarithms, which is an important foundational topic in the IB Math, AA, SL, and HL subjects. Okay, so let's jump right in. I will be covering a total of 5 questions today. So the first 3 are from past papers, and the last 2 are from our EdXP database. Okay? So let's have a look at this first question, which came from the May 2016 Time Zone 1, Paper 1. Okay, we want to find the integer values of m and n for this expression. The first thing I note is that every term has a different base. So what we want to try to do is to change them all to have the same base so that we can simplify the expression and hopefully find m and n. Okay, so let's change m to log 3. So m, if I want to change it to log 3, it's 3 power m over here. Okay, if you use the power law, you can bring m down, and log 3 is equal to 1 actually. Okay, let's keep log 3 for the second term, but perhaps with using power law, I want to bring the m up as well. Okay, and let's do a change of base here. Okay, so that'll be log 3, 6 over log 3, 9. Okay? And this is actually equal to, this guy over here is actually equal to 2. Okay, so that'll be 5 log 3, 6. I can simplify the left-hand side by combining both logs. Okay, so it'll be 3 to the n over 2 power n. Okay, this is the second log rule. And I can also bring the 5 up over here. Okay, as we can see, it becomes very simple. I can actually cancel out the log 3's. So I'm left with 3n over 2n equals to 6 to the 5, which I can change to 2 to the 5, 3 to the 5. Okay? And on the left, I can express them as index notation. So that'll be 3 to the m times 2 to the minus n. So it's getting very clear now. Okay? So 3 to the 5, 2 to the 5. Therefore, m must equal to 5 and n must equal to negative 5. Okay, so this is a paper 1, no calculator needed. Okay, so I hope you got this first example. I'll move on to the next example. This question came out in the May 2016 Time Zone 2, Paper 2, Question 3. So we want to solve a pair of simultaneous equations, unknowns x and y. First thing I'll do, I'll label both equations, 1 and 2, okay, to be very clear. Equation 1, I will always try to make the same base, so that will be ln y over x is equal to 2, but I'm going to change 2 to ln e squared. Okay. So now they have the same base, I can actually cancel this out. So y is equal to e squared x. Okay. It could be quite useful later on. Equation 2, I try to simplify both terms. I can add them together. Okay. So I get ln x squared y cubed in brackets here. And 7, I will change to ln e power 7. Okay, again, I can strike out the ln, so I get x squared y cubed is equal to e power 7. Okay, since I need y cubed, maybe I can cube both sides for equation 1. So I get e power 6 x cubed. Okay, so therefore I can substitute this in. I get x power 5 e power 6 equals to e power 7. Okay, so x will be equal to e to the 1 over 5. That's for x. And to find y, I can sub it back in to any y equation. The easiest one being y equals to e squared x. And I will get e to the power of 2 plus 1/5. So that will be 11 over 5. Okay, and that's for the second example. Let's move on to the third past year paper example. So this came out in the May 2015 Time Zone 2, Paper 1, Question 9. So we want to find the set of values of a for which this function exists. So this is a log base a x graph. Okay, so it is important to know, even before you start this question, that any log graph must look something like this. Okay, It is the inverse of an exponential graph. And we wanted this to exist for all x elements of real positive numbers, which is the graph over there. Okay. Immediately, we know that A must be greater than 0. Okay, the base must be greater than 0 in order for the graph to exist. There are no negative values on the horizontal axis. And we must also know that A cannot equal to 1, because if A is equal to 1, we don't have a log graph, we simply have a horizontal straight line, constant. Okay, so that's for part A. Okay, for part B, given that log xy equals to 4 log yx, find all the possible expressions of y as a function of x. Okay, and the first thing again we notice is that the bases are different. So I'm going to try and change it. I can power law and bring the 4 up. Okay, and let's maybe change all the bases to x. So we have log x, x power 4. So this is the change of base law. We have log xy. Okay, and this is actually, the numerator is just 4. Okay, and we have another log xy over here. Okay, so if I were to cross multiply, log xy squared is equal to 4. Okay, this is quite interesting, which means that two possible solutions, okay, either log xy is equal to 2 or minus 2. And since they want it expressed as y as a function of x, y must be equal to x squared or x to the minus 2, which is 1 over x squared. Okay, now I'll move on to some of our EdXP questions. So these can be found in our EdXP platform. Feel free to try some of them out. So this is a log question. Let's try to solve it. We have log, let me zoom in. So we have log base 7 of this chunk here equal to 0. Okay, so what I will do is actually try to simplify this very quickly. Too many brackets. So let's bring the log 7 over. So log 7x plus 3 plus log 7x minus 3, I can actually multiply them both together. Okay, this is the first log rule, logarithmic addition. Okay. 7 to the power of 0 is 1. Okay. So that helps us quite a bit. I can continue further by removing the next log. So I have x plus 3 times x minus 3 is equal to 7 power 1, which is 7. Okay. Hope you guys understand that. We can actually simplify this now. A plus b times a minus b is a squared minus b squared. Okay. So therefore, x squared will be equal to 16, and x will be plus minus 4. So I believe the correct answer is C. I'll move on to the last example, also from our EdXP database on logarithms. So let's read the question. Find the values of x and y such that this equation and this equation apply. Okay, so let's look at this. Quite interesting. So we have log 4x all squared equals to log 4x squared. So left and right, these two are very different. Okay, but they actually comprise of the same entity. What I will do is that I will try to simplify. This looks like a little bit like a quadratic expression to me, because the right hand side, I can use the power law to bring down the 2. Okay. And what I have is actually a nice quadratic expression. If you don't see it, let me write it down. So minus 2 log 4x equals 0. I can actually factorize out to solve this 2-term quadratic. So it's log 4x, open bracket, log 4x minus 2. Okay, quite interesting. So therefore, log 4x must equal to 0 or 2. Yes, which means that x must be equal to 1 or 16. Yeah, so that's 4 squared. So we have two values here. Okay, but they may not all apply. So let's look at the second equation. I definitely want to merge on the right hand side the two terms. Okay, and I get x plus y is equal to xy. Okay, when we have an equation like this, we have to reject x equals 1 because it will not fit into that equation, which means that x equals to 16. 16 plus y equals to 16y. So y must equal to 16 over 15. So the answer, I believe, is B. Okay. That is the end of my exponents and logs video. Feel free to check out our other videos or even try out our questions on our platform. Thank you.